All right, welcome back. We're going to move on to calculation number 2 on the gas stoichiometry lab report. Recall that in calculation number 1, we used the length of magnesium, and from that we found the mass of magnesium. For calculation 2, we're going to use that mass of magnesium just calculated to find the expected volume of hydrogen gas that would be collected if this were at STP. In other words, we need to do a stoichiometry problem. Then when we're done, we're going to convert this into milliliters. Remember, when you do a stoichiometry problem, it's always a good idea to start with a balanced equation. You may have already written this balanced equation during the lab or as one of the prior steps to your lab report. It should say that Mg plus HCl yields MgCl2 plus H2. And when this equation is balanced, then you're going to have a 2 in front of the HCl, and you should have 1s in front of everything else. Remember, you don't need to write those. Okay, so what we're going to do is we're going to use our previous answer, which said that we've got 0.0. Now remember, you're using your own numbers, but this is from some student data that I collected. Looks like I have 0.0. Stand by. Here we go. Okay, from my previous problem, I had 0.0413 grams of magnesium. And in this problem, they're asking me to calculate the volume, which is the liters of hydrogen gas. I'm going to do that using a stoichiometry problem. Take 0.0413 grams of magnesium as my given. And in following the rules of stoichiometry, the next thing I do is I convert from grams to moles. And in order to do that, I need to look up a molar mass from the periodic table, which I've already done. That's 24.31 grams for every mole. In the next step of my calculation, I'm going to put in a mole ratio. I go from moles of known, which is magnesium, to moles of unknown, which is hydrogen. And then in the final step, I need to convert this to liters, so I'll put moles of hydrogen on the bottom and liters of hydrogen on the top. Recall, if the gas is at STP, then we can always use the molar volume of 22.4 liters for every 1 mole. Also recall the mole ratio, which I've not filled in yet, should come from the balanced equation. So I've got a 1 in front of the magnesium and a 1 in front of the hydrogen. Those numbers are going into my equation here and here. And then finally, it's a good idea to cross out units to show yourself that all of the units have canceled except for the desired units, liters of hydrogen in this problem. So all that's left to do is to calculate some numbers. I'm holding my calculator, which still has the answer to my previous calculation on it with plenty of extra digits. More digits is better, so try not to round off your answers over and over again, but keep all of your digits until the end of the problem. You don't necessarily need to write them all, but you should use numbers that have the maximum number of significant digits when you're allowed. So I'm going to take that last answer and just multiply it times 22.4 and divide it by 24.31, and this gives me a new answer of 0.038062 and a bunch of more digits. I'll just write down 0.0381 liters of hydrogen. And I'm not quite done yet because the instructions also wanted me to convert this to milliliters. So I'm out of space. I'm going to do that conversion right underneath here. Liters of hydrogen. and we want to convert that into milliliters. So again, if I can just get these units on the bottom, they'll cancel. And if I can get these units on the top, that's what I'll have in my answer. The milliliter to liter ratio is 1,000 milliliters for every 1 liter. Go ahead and cross out some units here. And I don't really need a calculator for this. I can see the answer is just going to have a decimal that's moved 3 times over, which would be 38.1 milliliters. It's the volume of hydrogen gas that I would have collected if conditions were at standard temperature and pressure. And this is the end of calculation 2.